I think I forgot to start recording, but that's okay. I'll just record a video of this later, so that's completely fine. But yeah, these slides will be posted on the Fightable website, and the recording of this video, which I will redo later, will also be posted on the Fightable website as well as YouTube. So yeah. So yes, so not all IEDs, yeah, no problem. Not all IEDs have a comment feature. So what does this mean? Sometimes in your development environment, which is what an IED is called, they don't support a comment feature, so you might have to write that down physically or something else. Okay, so program design and development. So kind of just like copyright laws, citing your sources is super, super important because you don't want to get in trouble for copying code. In fact, most teachers are pretty strict about this. It's a little harder for Blockly and like things like that. But especially for like Python and Java later on, it's really, really important to not copy code because it can be easily identified, when code is plagiarized, because there's similar to essay plagiarism checkers, there are also lots of times there are also code plagiarism checkers. So just make sure not to plagiarize code, you must cite code if you have taken it from somebody else as a starter code, or have even just looked at it for reference, just to be safe. So there's lots of different rules, and all of these rules can be found in this workbook that I've linked here. And obviously, I can't really click on this link without leaving the slides, but it kind of just details what types of ways you might cite your sources. And so usually this would be like putting the original creator of the code, where you found the code, a link to the website, and also like retrieval date, origin, and things like that. But basically this workbook is very similar to Purdue OWL's MLA website thing. So yeah, it's pretty much a resource there for you to look at. It might be a little different because if you're using, Snap or Blockly or things like that, it's going to be a little harder to do because you won't have necessarily the way of like the perfect ideal commenting place compared to like Java or Python, but there's definitely a way to comment on most of those different things. All right, so sorry, I kind of skipped a few slides. But so now you should be able to develop a program using the development process, develop a program. Ooh, that should not be the same thing. Describe a purpose of the code segment or program by writing the documentation, acknowledging code segments used from other sources, and you might be a little confused now, but those are definitely things you should be able to do eventually. So yeah, you can go over these slides if you ever need to. Okay, so now we're going to do 1.4, which is identifying correcting errors. So typical errors within code are logical errors, syntax errors, runtime errors, and an overflow error. So logical errors are when the code correctly compiles, but when it executes, the output is incorrect or not what you expected. So kind of if you think about this means that the logic behind the code is incorrect and not the code itself. So that means all your syntax is great, you have written your code correctly, but when you put your inputs into the code, it comes out with a completely incorrect answer. For example, if you were making a program that added 2 different numbers, and you did 1 + 1, and then it came out with 3, that's obviously a logic error because 1 + 1 is not 3, and obviously your code is compiling, so that would be a logic error instead of one of the other errors. And then a syntax error is when a code is improperly written for the syntax of that language, and a syntax is kind of the order of which code components are. So for example, at the end of every single Java line of code, you usually have a bracket. So that would be like a syntax thing. So that is when the code is not able to compile or run. So it will usually not output anything because your code just isn't right. And that's a lot of the times what happens in coding. You miss a semicolon, it won't run. And that's pretty frustrating, but there are different ways you can find these errors. And so a runtime error is when a code cannot execute a task properly as you run the code. So that means there is an error as you're running the code. So the code compiles and runs, kind of, but there's an error when it's trying to run. So that means the syntax is good, but there's something wrong with the code itself that is preventing it from running all the way. So it's different than a logic error, because logic errors do output something. Runtime errors will not output anything. And then lastly, an overflow error is when a computer is trying to handle a number that is far too large for the program that is running on it, and they must replace the new numbers with different values. So an example of an overflow error might be I'm not sure if you have one of these, but on those water fountain machines where they have like numbers of how many water bottles they've saved, once the amount of numbers hits a certain number, there's going to be too many numbers for the counter, and it's going to overflow. It'll either go to like error, or it'll go back to 1 or 0. So that's kind of a thing that will happen. And so how do we determine what certain coding errors are? So test cases, hand tracing code, visualizations, debuggers, and adding extra output statements can all help you understand what's happening in the code and understand what might be going wrong within your code. So test cases are when a programmer can use predetermined or defined inputs to plug into the program to produce an output. So when you are kind of finding these inputs that you want to put in, you have to know what is going to be outputted if the code were to run properly in an ideal world. And so you put this in, and if it doesn't work, then clearly your code is not working. But if it does work, that means your code's working for right now, so that's pretty good. So boundary cases are another version of a test case to see if a program is performing accurately. So basically, boundary cases, you have to know each bound of the program. And so for example, if a program only took in the letter A, you might try to plug in C and D to see if that would work. And if C and D did work, that would mean that the program is not running correctly because it is taking in more than what it's supposed to. You also do this with numbers. So if you're like, okay, my program can only take numbers from 1 to 3, and then you put in 4, and 4 worked within your program, that would be bad because it's not only supposed to take in 1 through 3. Another way of finding errors is hand tracing code, and this is probably one of my favorites. Hand tracing code is not necessarily actually tracing code with your hand like this, but you can kind of go through each line, determine what's going to happen at the end of each line of code, and then go through and see what it should output. So for example, if you're going through your code and you're like, oh no, this is so wrong, this is going to make the answer 4, which would ruin the rest of the code, then you can figure out that's the error. You can fix that, and the code should be fixed. Visualizing the code is maybe when you are designing code and it's not working, you might make a graph or a flowchart of what your code's supposed to do, and then you can kind of go through and make sure each part is working properly, and you can kind of see errors in your logic more easily, because if you were drawing a flowchart and you're like, oh, this is completely wrong, it's going the wrong way, it's going to a different output, then you can see, oh, that might be where the error is occurring in your code. And then that would be the quickest way to find an error. There's also visualizer programs online that can take your code and make a visualization of it quite easily. So that's also another really important tool to use. But just as a disclaimer, visualizers are really helpful to see what's wrong with your code, on outside projects. But for College Board, there's not going to be any visualizers for you to use on the test because it's just a multiple choice question test. So definitely don't rely on those when trying to determine like errors within code, because that might be a question of where like there's like a little segment of code and it's like, why is this code wrong? Like what like out on line 10, what is wrong with it, or things like that. Definitely there will be no visualizer for you to use for that, and there definitely will be time to make a visualization of the code yourself. So definitely a hand tracing code and maybe putting in a few test cases would be pretty helpful on the test. Okay, so there's also debuggers and adding extra output statements. So for some reason, this sentence did not appear for the debuggers, but debuggers are specific softwares that find all the bugs in your code and then they output them to you so that you can see what's wrong with your code. And those are really helpful, but once again, definitely don't rely on debuggers too much, because sometimes they do miss things, and also sometimes it might be faster if you just hand trace the code yourself. Excuse me. And then the last way is adding extra output statements. So this kind of sounds weird, but if you output each section, kind of like how I described in the incremental development process, if you kind of output each section of your code to find like certain numbers, you can kind of see where one part of your code might have gone wrong. So if your code is maybe adding 4 different numbers together, you could add the first 2 numbers together, and then that answer plus the next number, and then that answer plus the next number. So if one of your program lines is wrong within this like bigger equation, you can kind of figure out where you went wrong. And so adding outputs would let you see like what it would output and if that was wrong or right. So those are pretty helpful ways of figuring out errors. Okay, so now you should be able to correctly identify and correct an error within a program or an algorithm. And you should also be able to identify outputs and the corresponding expected outputs or behaviors that are used to check the correctness of an algorithm or program. So obviously after like a short overview of the topic, you might not be able to do this completely entirely, but at least you kind of know what you're going to be striving towards when like identifying errors and things like that. So just like as a general disclaimer, these all of these different learning objectives will be practiced throughout all different types of labs and projects, hopefully, whatever your teacher assigns. So like identifying these outputs and inputs, you probably wouldn't have a whole class period just doing that. It would be more like in a project, if you were messing up, then you could probably identify errors through this lab project, kind of like hands-on activities. And then like identifying outputs, you probably would do some test cases to make sure your program works, and so that would kind of be like you're using this skill in real life. So that is, just as a disclaimer, most of AP CSP is more or less implementing what you're learning, like textbook wise or like slideshow wise, into real life labs and things like that, because I feel like that's definitely a better way of learning, kind of sticks with you better, because before I had no idea what errors were, but now I know what runtime errors are and things like that through having those errors on my code itself. And so yeah, that's all I really have for today. That was quite a lot of things. So if there's anything that needs to be gone over again, just type it in the chat, or if you have any questions or anything like that, you can go ahead and let me know. I'm here just to help you guys with any questions or anything like that. And if you have any specific questions on your homework or in your class, or you're worried about something, just go ahead and let me know. You can turn on your camera and turn on your mic, or you can just type it into the chat. And if you have nothing, that's completely fine as well. All right then. I'll just stay here until the hour's over because I usually want to do like office hours from 3 to 4. So I'll just stay here until office hours is over. Um, but if you don't have any questions, you're free to go. But yeah. All right. Okay. Thank you. Thank you for coming. Really appreciate that. I hope you had a wonderful time. And this video will be re-recorded and slides will be posted on the website and also in the Slack, just so everyone else can view them as well.
Bye, thank you.
All right. Bye. Thank you so much.